Hey, I had a request to make another video to do some more examples with the infinite geometric series, and of course, absolutely, I'm willing to do that. I'm always a little bit worried when I put examples in front of you that I'm giving you so many that it either overwhelms you or you just get bored with it. So I'm always happy to. I love to do the math, so anytime you want me to make more videos, that's going to be fine. So I copied one of the problems over from Alex. Here we've got, well, two different problems, of course. And I've got our formula here. And then, of course, I've got written out as the sum is equal to your first term over 1 minus the rate. Another way that I could write this is that the sum of A1R to, say, the I power, and then going from your first term to your infiniteth term. I don't know, how would you say that? That you, in a college textbook especially, would see the formula written out more like this. So you're going to want to, what I would do first is just identify what your A and your R are. So your whole A, the whole purpose of that is it's just your first term. And you always remember, sometimes in these series we had numbers that were in front of the original. We don't have that here. Not on these problems, but I could, and so that's where that A term would come from. In this case, I don't have that. I can see, let's do the first problem first. I can see that my first term, that was an awful arrow, is going to be -5. And then I can see that I multiply that by -5, and then I multiply that by -5. And remember, that right there already goes against our rule about what will work for having it be an infinite series. In other words, you're adding numbers forever, but then getting an actual number out of that. Anytime these numbers are above 1 or lower than -1, then your sum is going to add up to infinity as you keep adding all these numbers together. We have our first term, and then I'm going to take that term and I'm going to multiply it by -5 again. And go ahead and highlight just that cell, drag it down as far as you want to go. Let's go, I'm going to go to 50 terms, let's say. And then I'm going to add all those terms together. And I can see I get a ridiculously huge number. I mean, this is, remember, 10 to the 34th power. If I want to write that out in terms of just longhand, I can come over to Format Cells and say I want a number. I don't need any decimal places. And this is how big that number is. I definitely would say that that number is heading towards infinity. And when it heads towards infinity, that is when we're going to say no sum. We only are going to count it as having a sum if the answer we get out is not infinity. If we can keep adding our numbers forever and ever and always, and they fit inside a box of a certain size. So that first one, I would say no sum, because my sum does equal infinity because of this rate. For the second problem, I can see that when I put in I equals 1, my first term will be 2/3 to the first power, or just 2/3 equals. And then because this, well, actually, because if I list out my numbers, I get 2/3 was my first term, and then because of this right here, my second term would look like this. My third term would look like this, and so on and so forth. I can see here that I'm multiplying by 2/3. That's my rate. And because 2/3 is less than 1, it turns out if I add up all these numbers and keep adding for infinity, there is some size box that all of those things will fit inside, if I were to think of it as some sort of area problem. I know that I can fit it into a box anytime I'm multiplying by a number that's less than 1. Even if my starting value is not, like let's say this is one of those cases where I had some number out in front, I still would be able to take that sum, add up all my numbers all the way up until infinity, or an infinite number of numbers, and I would still have some size box that it would fit into. So this is where now my formula is going to come into play. You want to see first just, can you take the sum? If you can't, just stop right there. Well, I put it in the answer book, but just stop right there. But if you can take the sum, then you want to use this formula. And this formula says that if I take my first term and then divide it by 1 minus the rate, which it just so happens my first term and my rate are the same thing this time, that's not always true, then this right here is my infinite sum. Now, I don't want to leave it like this because that's too ugly. You never want to leave fractions inside fractions. If you can simplify the problem, simplify the problem. No teacher is going to want you to give the answer like this. I'll accept it. Alex won't, but I in normal circumstances, I would accept it, but even I don't like it. Like, go through, do the work, show me you know how to do the math there. So remember, this all comes down to my rules about fractions. The top is already simplified, so I just leave it be. On the bottom, I need to have a common denominator, and my denominator is 3. So I need a 3 here, and since I have 1, I need a special form of the number 1, which means I have just 3 over 3. 3 over 3 is the same thing as 1, but it's written in a way that has the same denominator as the fraction we're using. Okay, once you have that, then you subtract the top with the top, but the bottom you leave alone. So I'm going to still get a 3rd here. And 3 minus 2 is just 1. And then you've got to think about my little sister. I like to flip her upside down. I, the first one, stay with my head where my head goes and my feet where my feet normally are. But my sister, who's the second one, I like to flip her upside down. If you've heard me tell the story before, you know it's been a couple years since I've been able to do it because she runs faster than she used to after I hit her head flipping her. She's taller than I am. Okay, so here I multiply fractions straight across, but I want to look for opportunities to cross cancel. Sorry, that's getting kind of busy, but I'm going to look for opportunities to cross cancel. And I can see that on this one opportunity, I have a 3 on top and a 3 on bottom. Anytime you see that, something upstairs and downstairs, they're going to cancel out. 2 and 1 won't really cancel. If I divide 2 by 1 and 1 by 1, I still come back to the same place. So I now have 2 over 1, which I do want to simplify down to 2. So that means that if I add together my sum of 2/3 to the I power going from I equals 1 to I equals infinity, if I do that forever and ever and ever and keep using that pattern, my answer will be 2. And if I want to check that on Excel, let's get rid of all of this and all of this. And I type in my first number in my series. And then remember, you need an equal sign. Oh, forgot about that. So Excel will make a prediction about what it thinks you're using. And if I type in 2-3, it thinks I'm talking about the date February 3rd. So if that happens, you come back here and you right click and go to that format cells again. And tell Excel that you want to use, I want to use in this case, I'm going to go ahead and say a number. And you'll have to delete it and start again. So there's 2/3 as a decimal. I could have also put it as a fraction, but since my answer is a whole number, that's where I'd made the judgment call not to, but I could have. Okay, so now I'm going to hit equals first number times 2/3. And it gives me the next number. And I'm going to keep adding, or keep putting all these terms together. I'm going to stretch that down so my formula goes down. Oh, let's see. Didn't notice here, I wasn't at the top. Doesn't really matter, honestly, but I'm going to go ahead and move it so that it's in the first row, so I can see and count how many terms I have. Okay, so I've got 33 terms. That's good enough for now. So I'm going to hit equals sum to add them all together. And I get, out of that, 2, which is what I had predicted. Alright, so let's do another problem. Let me copy and paste another something from Alex. I'm going to go ahead and delete all of this. Hope you are okay with that. Yeah, this one will be a good problem. Okay. So I like this because it's got an A value in front of the rate. So this gives us a little bit more to play with that we didn't necessarily have before. Okay, so again, my formula that I'm going to use is, oh, need my brushes, is going to be A over 1 minus R. And I like to put a 1 there just to tell me it's the first term. Later you're going to see functions where it's going to have A1, A2, A3, A4, etc. just to tell you which term you're looking at. Okay, so on this first one, I can see that my first term was 2. So my A is equal to 2. And I can see then that I multiplied by 5. And then I multiplied by 5. And then I'm going to assume I kept multiplying by 5. And again, right there, you're done. That number is bigger than 1 that you're multiplying by. That's an infinite sum. That's going to, in other words, your sum will actually equal infinity. So this one would be no sum. Remember, any positive or negative number that's greater than 1 or less than negative 1. That just, it won't work. It'll give you a positive or negative infinity. So we're done with the first one. On the second one, if I were to write it out, and I do think it's a good idea, one of the skills that you're going to need, not in my class, but in a later math class, is to know how to change this into the summation notation and how to write this out just as a list of terms. So in other words, you're going to need to know how to go back and forth between these skills. I'm not going to stress that right now, but I am going to go ahead and write this out as a set of terms. So I can see that when k is 1, I'm going to have 4 times negative 3/7 to the first power. And then my next term is the same thing, except for squared. And then it keeps on going. Third plus blah, 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 blah. I can see that my first term is going to be 4 negative 3/7, 4 times negative 3/7. And the rate that I have is I can see I'm multiplying by negative 3/7 every time. And that is a number that is smaller than Well, it's between -1 and 1. So it works. Its absolute value is less than 1. It's perfect. In other words, you will get a sum out of this that will not be infinity. So my rate here looks like that. So I just need to put it into my formula now. One minus -3/7. And I'm going to have a little work on top and bottom to do this time. So I've got 4 times -3/7. Remember, when you're multiplying fractions together, remember you multiply straight across, which means if you don't have feet on one of your fractions, you need to give it feet. So that's why I put the 1 underneath. And then I multiply just straight across. So on the top I'm going to get -12, and on the bottom I'm going to get 7. Then that was all over 1 minus -3/7. And remember the trick. My middle school teachers would always have us repeat over and over again that minus a negative is plus a positive. They cancel each other out. So when I add these together, again, I'm going to want to use my rules. I'm going to need to have common denominators. So my 1 I turn into 7/7. 7/7 is a special way of writing the number 1. And then once I've got common denominators, I'm going to just add the tops. The denominators do not get added. The denominators only tell you how big the piece is. But I want to know how many pieces I have. So I get 10/7. And then now it's time to think about my little sister. She gets flipped upside down. I do not. And I look for opportunities to cross cancel. And very conveniently, I see I've got a 7 downstairs and a 7 upstairs. I also see that both the numbers that are left are even. That means I can divide both of them by 2 and cancel that 2 out. When I do that, 10 divided by 2 is 5. -12 divided by 2 is -6. So, and I should have put probably that when my 7's canceled out, I am left with 1's there. And now I multiply straight across. -6 times 1 over 1 times 5, which just gives me -6/5. And let's check our work in Excel. I started with 4 times, I'm going to put parentheses around it just because of the negative, -3/7. And then I took that term and I multiplied it by -3/7. Oh, and I forgot to click on it, so I need to come back here and click on that first term. So you see hopefully my modification to my formula. It didn't like that. Why didn't it like it? I think it probably still has to do with this negative here. But it's not loving. I'm going to use their help to figure out where my error is. Okay, I think it thinks that I want to subtract the number. I don't want to just get rid of the negative because my terms are going to alternate between positive and negative, and that's going to have a huge effect on my my value. So here's what I'm going to do instead. I'm going to find out what -3/7 is equal to, and I'm going to use that value instead. So I'm going to say equals 4 times this value, and then I'm going to say equals this value times, and I'm going to write it out this time on purpose. Remember, if you don't write it out, you have to put in those dollar signs so it references the same number each time. But I'm going to go ahead and write out -0.42857. Okay, And then I find those values. This is the first 33 values in the sum. Let's go ahead and find it from there. When you have something that's times 10 to the negative 12th, sorry about that. My husband's turning on the faucet outside, and we don't have insulation here, so you can hear it all. Okay, so I'm going to take the sum of this, and I get this number here. Now I got negative 6/5. One's a fraction, one's a decimal. If you really want to see if they equal each other, take equals negative 6 divided by 5. And there you go. Same thing both times. If you want me to do any more examples, I am happy to. Just let me know. I will chat with you as we go, and tomorrow I'll be uploading your practice test and your actual test. And of course I'll take any questions you have with that. Just let me know. So see you later, and again, let me know if you want me to do any more of these examples.